So hello everyone, this is going to be the next lecture. Today we are starting a new unit and the unit is inflammation. Before I start this, I want to tell you guys, please focus on the basics of pathology. The chapter like cellular adaptation, the cell death, the inflammation, neoplasia, the immunology. If you have completed, these 4 and 5 topics by heart, like you know everything, you didn't just remember the facts, but if you have the concept, trust me, you have understood entire pathology. Because if you're studying CVS pathology, respiratory pathology, GIT pathology, everything is just these 4 or 5 topics. Where there will be cellular damage, cell death, or the cellular adaptation. There will be inflammation, for example, hepatitis, inflammation of liver, gastritis, inflammation of the stomach, pancreatitis. So that's just inflammation. Neoplasia, it means there will be cancer. For example, it can be the cancer of bone, osteosarcoma. There can be glioma. So neoplasia, immunology. You will study about hypersensitivity reactions. Maybe you will study asthma also. You will study SLE and all those kind of reactions. Those are immune or autoimmune or the hypersensitivity reactions. So please focus on these 4 or 5 topics. Today's topic is inflammation. So before I write it, just I want you to say this in your head. What do you mean if someone sees inflammation? You just think it's just redness, or you just think it's pus? What is it? What is inflammation? Well, inflammation means a protective response of any vascularized tissue against a dangerous stimuli. What did I say? It's a protective response of vascularized tissue against what? Against harmful stimuli. Two questions here. Why did I say vascularized tissue and why did I say harmful stimuli? First of all, if you are aware, inflammation is mediated by two things, either by the inflammatory cells or inflammatory mediators known as cytokines, chemokines, and all those stuff. So, where are they present? Inflammatory cells like neutrophils, eosinophils, the lymphocytes, macrophages. Where are they present? They are present inside the blood. They are the component of formed element. What about the inflammatory mediators? While they can be secreted by the interstitial tissue cells, they are mostly acting where? Acting on the cells which are present inside the blood. So if there is no blood supply to a tissue, there will be no protective response. For example, if a virus attacks your hair, do you think your hair will have inflammation? No. Hair doesn't have any blood supply. If you have heard this, like I will teach you later in the immunology, during the time of grafting or during the time of transplant, let's say you are transplanting someone's liver, you need to give the person agents which reduces immune activity. But when we are doing the transplantation of cornea, do we need something? Do we give any substance which reduces immunity? The answer is no, because cornea doesn't have blood supply. So protective response of vascularized tissue against harmful stimuli, that is our inflammation. Now this dangerous or the harmful stimuli can be anything. It can be foreign body, for example splinter. Maybe you were taking rose for your girlfriend or boyfriend, but needle pricked your finger. That is a splinter. That's a foreign body, and your body is going to act against it to preserve your system. Secondly, dust. When you are playing, you inhale dust. So is your dust sugar that your body will say, oh wow, I got my dessert? Answer is no. It will remove it. Your macrophage will come and they will remove it. What about, let's say, the pathogens? They're also harmful stimuli. So yeah, if there is a dangerous pathogen, for example, Escherichia coli, Mycobacterium tuberculosis, your body will remove it. There can be immune reactions also, maybe autoimmune conditions. So inflammation is not just for like if that is bacteria, I will do remove it, and for the rest I won't do anything. anything which is foreign to your body, anything which is foreign to your body will recognize it as a invader and it will try to remove it or get rid of it. And the process by which we do it, that is known as inflammation. So how inflammation actually works? First of all, you sense that there's an offending agent. Second, you have sensed that there is offending agent. Second is you recruit the cells and proteins which can take care of it. For example, recruitment of cells. We will see neutrophils, lymphocytes, macrophages, proteins like cytokines, chemokines, interleukins. So first we sensed it. Second, we recruited the cells which can take care of it. Now we have recruited. Now there will be the activity of those cells. After activity, they have destroyed the intruder. Killing or destruction of invader. Fourth one, now the invader is dead. What will you do? You will terminate the activity. Because if you don't terminate the activity, maybe you can destroy your own tissue. And in case you have destroyed own tissue, you will repair the damaged tissue. And this repair leaves scar. For example, if someone has tuberculosis, the parenchyma of the lung gets affected and that leaves a scar, which in generally we see as fibrotic changes. Well, you might have heard me, I mostly take Mycobacterium tuberculosis as a template. The reason for taking it as a template is, if you don't study tuberculosis in India, you might not pass exams. It is very necessary. We have different protocols. We have different regimen. For example, RNTCP, Revised National Tuberculosis Program. So please study tuberculosis. You are studying pathology, and right now you can study tuberculosis in a large number of topics because TB bacteria can affect any organ, and you can study this in any organ system pathology. And you will be studying, the drugs which we use in the pharmacology. So please study it because there are millions of people in India who are affected. Be a nice and noble doctor. Don't study just for the exams, but study for your people, your community. Now, we saw what is inflammation. But have you seen inflammation anywhere? Like, let's say this is sun. You went outside. You are out. The sun caused what? The sun caused you tanning. What is it? This is also inflammation. The sun rays actually damage your cells. Once there is a cellular damage, I have told you in the accumulation of the intracellular pigment, they release melanin. This melanin is what we call as tannin. So what you think is the tannin is nothing but cellular damage. When the cell is getting damaged, that produces intracellular pigments. Got it? So use sunscreen. So that is it. Now, you might have studied, might be your professor or might be your friend or might be your sisters. She might be teasing you, hey, tell me what is cardinal sign of inflammation. So what is cardinal sign of inflammation? See, first of all, Cardinal sign of inflammation was given way early, like it was Celsus who gave 4 cardinal signs, which was calor. You remember calorie, the SI unit of energy or the heat, SI unit of heat. So calor means heat. Second cardinal, I will explain what is it, everything. Second is rubor. Rubor means redness. Third is tumor. What is tumor? Tumor is like a ball-like structure or something. This is nothing but swelling. And what is fourth? Fourth is dolor. And what is dolor? That is pain. This was, given by Celsus. But there came our Rudolf Virchow. He said, if any organ or any tissue has heatness, redness, swelling or pain, after some time the organ or the tissue will not work properly. That is known as functional lysa. Lysa means cessation. Functional means function. Cessation of the function. So that is a product of these 4. So he just came and he just, there was everything there and he just baked the cake. So the 5 cardinal signs of inflammation. Now tell me why it happens. Suppose this is blood supply, the blood vessel. There is a site where inflammation takes place. The blood vessel will undergo few things. First of all, there will be vasodilation. It means the blood vessel has dilated. That will cause what? That will increase the blood supply. Now, if you increase blood supply, you increase what? Blood is responsible for carrying, it's like responsible for taking heat from the center to the periphery. That is why during the, cold, when you step outside, your vasoconstriction happens in your hand and your hand becomes very cold. But you do the exercise and then again the vasodilation happens and the blood starts going towards the limb and it feels hot. So blood isn't just responsible for the transportation of food, gases, minerals, but also for the distribution of heat. So if you are increasing the blood supply, it will increase the heat. That is why during the sign of inflammation, there will be vasodilation, increased vascular permeability and everything, and as a result the heat will increase because there is more blood supply. If the blood is more right now the blood supply has increased, blood is red, so the tissue will appear red. Now I said vascular permeability, but there will be increased vascular permeability also. Suppose this is endothelium normally. At the time of inflammation, the spaces will appear between endothelium so that the fluid from the blood can go outside. Now if fluid is going outside, it means this will get accumulated under a surface. Does it appear like a tumor? Yes. This is the reason why we call it tumor or the swelling. Why? Because interstitial fluid, the fluid from the blood is going and accumulating in the interstitium, and that fluid is known as exudate. I will tell you everything. I'm just giving you a very short, discussion. What about the dolor? See, if a tissue is stretching, it will activate the stress receptor, the pain receptor, and there will be various molecules here that will regulate the pain and you will feel the pain. For example, there will be bradykinin, that is responsible for the pain. So 5 cardinal signs, 4 given by the Celsus, 5th given by the Rudolf Virchow, the guy who baked his cake. So that's our cardinal signs of inflammation. Now if your newborn sibling or maybe someone came, he asked you trick or treat, and you say trick, and he asked you, tell me what are the types of inflammation, what will you answer? You should not say like this is acute or chronic, serous or fibrinous. You should ask him, hey, what are the basis, like on what basis you are asking? Like someone asks you how many types of human are there, You can say he can be Indian or Pakistani or maybe Bangladeshi or maybe Russian or maybe Indian. Or you can say he might be taller or shorter. He might be white or black or brown. So there can be one thing can be of many type. The thing that separates everything is basis. On what basis you are asking. So if someone asks you what is the type of inflammation, we say there are a few. First basis is fluid. Like what kind of fluid is involved in the inflammation? If the fluid is watery, that is serous inflammation. If the fluid has collagen threads or the fibers, that is fibrinous inflammation. There are conditions in which they are seen together. For example, rheumatic heart disease. In that condition, there is a mixture of water and the thread which appears like bread and butter. So it is seen in rheumatic heart disease, and because it has fiber as well as the serous or the water, it is known as serofibrinous pericarditis. Got it? Similarly, if someone asks you about the serous inflammation, say pleural effusion. Pleural effusion is what? This is serous inflammation. Someone asks you about fibrinous inflammation. Answer, fibrinous pericarditis. Not serofibrinous, but the fibrinous pericarditis. Someone asks you purulent inflammation. For example, it is also seen in tuberculosis again. Here, purulent means pus. So here the fluid is pus. Next is catarrhal inflammation. When you have common cold, your nose starts to run, right? Fluid starts coming drooping. That is a mixture of mucus plus water. Rhinitis, that is the inflammation. And what kind of fluid is involved there? Mucus plus water. And what kind of inflammation it is? That is catarrhal inflammation. Now, it was one basis. So one trick completed. Second one, on the basis of duration. Now, if something is short-lived, what do we say? It is acute. But if something is prolonged, what do we say? Chronic. So inflammation can be acute inflammation or chronic inflammation. Let's see them side by side. Now tell me one thing. If a terrorist came into your city, you will call your army chief. But you will wait, your city won't wait for the army to come. Might be that your police officers will go there. So acute inflammation is like that. They will try to get rid of the terrorist before your army came. It might not be enough. If it is enough, that's okay. The inflammation will stop here. But if that is not, then the chronic inflammation will proceed. What do I mean? I said, suppose there is a bacteria. It came to the body. Your acute inflammation will come and it will try to take care of it. Will try to destroy it. But if it could not, then it will proceed into chronic inflammation. What do I mean is, this is shorter in duration and fast acting. But this is longer in duration. It means it takes time for it to come into the picture. And this is insidious in onset. Here, the local signs, the local and systemic signs of inflammation is prominent. But here, the local and systemic signs of inflammation isn't prominent. Now, the one thing which separates the acute and inflammation, besides these factors, is the kind of cells are involved. For example, you are in your pathology class, your professor came and he's asking you, guys, you will have your university exam, maybe internal or external if you are in a government medical college. And he will ask you, if the external professor comes and asks you, how will you differentiate acute and chronic inflammation under a slide? I'm asking you right now this question. How will you differentiate whether this is acute inflammation or chronic inflammation? Can you do it? Yes, acute inflammation has distinct kinds of cells which are involved, and chronic inflammation has very distinct kind of cells which are involved. In acute inflammation, mostly you have neutrophils, mostly. And in the chronic inflammation, that is macrophages, mostly. I'm not saying always, because if there is allergic response, there will be eosinophils in allergy. But if there is a viral inflammation or autoimmune condition, then there will be lymphocytes. Got it? For virus and autoimmune. For you, it is not artificial intelligence. This is autoimmune. For autoimmune condition, you are a medical student, not an engineering student. So for you, AI is autoimmune. Jokes. So jokes aside, this is our acute and chronic inflammation. One more thing about the acute and chronic inflammation is this resolves very fast, but it takes time. See, acute inflammation proceeds to chronic inflammation only when the pathogen is very, stubborn. And if the pathogen is very stubborn, then, it will try to, get 100%, like it will try to disintegrate it. But in doing that, it might be possible that you destroy your own tissue. So in acute inflammation, since it's very easy, like the pathogen is not so, it's kind of easy, you won't need to destroy it so badly that in doing that you destroy your own tissue. So resolves easily without tissue destruction, or at least that is not so prominent. But in chronic inflammation, there is tissue destruction. And what did I say? Tissue destruction repairs by scar formation. So tissue destruction by scar formation. Got it? This is our acute and chronic inflammation. Now, you might have studied this, like the phases of acute and chronic inflammation. See, like try to study it this way. Suppose this is a stadium. And this is a box. Or suppose this is a room in which all the players are present. So you need to play your cricket here. But the players are here. How they are going to reach here? Like, if the game is going to be here, players needs to go there. Similarly, if there is a site of inflammation, suppose in the lungs, and the inflammatory cells are inside blood vessel. So the inflammatory cells from the blood vessel need to go here. Similarly, the players needs to go to stadium to play. Similarly, the cells from the blood vessel need to go to the site of inflammation. In doing that, what is necessary? Players are inside a closed room. The door needs to open. Similarly, here the door needs to open. Only then the cell will come out, or the player will come out. This is what is known as the stages of acute inflammation. what happens is changes takes place inside the blood vessels and also the changes in the cells. That is our stage of acute inflammation. Let's see. This is also known as the mechanism of acute inflammation. Acute inflammation. In this, we see two kinds of changes. As I said, first will be vascular changes. Second will be cellular changes. See, what vascular change does is, it's like you will see there will be few stages like transient vasoconstriction, vasodilation, and everything. There is just two things. Normally, the cell inside the blood is present in the center, but it needs to go out. This flow, where the cells are present in the center and the plasma at periphery, this is known as laminar flow. But what if, we just compressed it and then suddenly expanded? What will happen? This laminar flow will convert into turbulence, or the turbulent flow, and all the cells which were present in the center will move towards the periphery. Now, since they have moved towards the periphery, what if we make a door for them? Now the cells will come out. So vascular changes means vasodilation, vasoconstriction, forming the gates, it means increasing vascular permeability. And cellular changes means going to the margin and coming out of the blood vessel. This is like just, a very summarized form so that you can understand what we are going to study right now. Let's study vascular changes. Vascular changes are the sum total of changes that occurs inside a blood vessel. It helps inflammatory cells to do its own part. Just give me a minute, let me connect my charger. That is our vascular change. Now, where this change occurs in? Does it takes place in arc of aorta or abdominal aorta? The answer is no. It takes place in small vessels like arterioles, capillaries, venules. Got it? This is our vascular changes or the vascular phase. Where it will occur? It will occur there in the arterioles, capillaries, and the venules. Now, how many vascular events are there? We have 4 in total. First is transient vasoconstriction. It is very short duration constriction of blood vessel. What does it do? It pushes all the cell to center. Got it? This is first stage of your vascular phase. It is very short and it pushes all the cell to the center. The second is vasodilation. Now, what does the vasodilation do? It increases the diameter. Now, if this was the normal diameter of the blood vessel, and if this was our inflammatory cells, you see in the center, the transient vasoconstriction, or the first one, pushed everything towards even the more center. But as the second stage came, the vasodilation, everything will move towards the periphery, by centrifugal force. So this is the second phase, which is our vasodilation. Now this vasodilation is regulated by certain molecules, and those molecules are histamine. So histamine regulated vasodilation, which occurs in arterioles, capillary, and venules. Histamine regulated vasodilatation. Now, why does this vasodilatation occur? To break laminar flow and form turbulence. What does this turbulence do? It pushes all the cells, not just RBC or WBC, everything, to periphery. And this, this moving to the periphery is known as margination. This is a cellular event, and for this vasodilatation is helping. This is the thing, vasodilatation. This is what we're causing our calor and rador. Got it? Two cardinal signs of inflammation. So we studied two stages: the transient vasoconstriction, the vasodilatation, and now we will study third one: increased vascular permeability. Now you did everything. Now the cells are present at the periphery, but they are still inside what? They are still inside the blood vessel. They need to come out. To come out, you need to, give them some space. You need to make some space for them. And that space, here, this is making the blood vessel more permeable so that things can come out. This is known as vascular permeability, and you are increasing it. So this is regulated by histamine again. Histamine and serotonin regulated increased vascular permeability. This is the most critical event, because if there is no door, how can they come out? So if there is a door, they will come out eventually. Even if there is no vasodilatation or constriction, they will come out. So increased vascular permeability is the most critical event, regulated by histamine and serotonin, and it primarily takes place in capillary venules. Which capillary venules? Post capillary venules. Now tell me one thing: if there is space here, if the cells can come out, fluids will come out too, right? The fluid which comes out from the spaces between the endothelial cells, those are known as exudates. So this exudate will go to the interstitial space. For example, here one cell, another one cell. So this fluid will go into the interstitial space, and this will cause, what? This will cause the expansion of the tissue, which we called tumor. This is nothing but the exudate. So this was our third. transient vasoconstriction, the vasodilatation, and the increased vascular permeability. Now tell me one thing. If this is blood vessel, fluid is leaking out. The fluid is going out. What will happen? Very less fluid will be left inside. So very large number of cells will be present inside. So this is known as stasis. This is the fourth phase or the fourth stage of your vascular changes. That is stasis. Since exudates are outside, or you can say since large volume of fluids came outside of blood vessels, what will happen? Viscosity will increase. Now there are more cells and very few amount of plasma, and what will happen? This will cause engorgement. Thus there will be a time when the cell will not be able to move forward. This is known as stasis. Got it? Any question? And I did not explain you this increased vascular permeability because the recent edition of Robbins, like the 10th or the 11th edition, they did not discuss it. But the previous, like the 9th generation or the 9th edition, they actually discussed 5 ways by which vascular permeability can happen. So you can remember it. So the first way vascular permeability can happen is endothelial retraction. As the name suggests, suppose this is your blood vessel, this is the lining cell known as the endothelium. These endothelial cells will contract, and as they contract, you can see the spaces appear between them. This is known as endothelial retraction. Got it? This is one of the most common mechanism by which vascular permeability increases. They are regulated by your, as I said previously, histamine, your bradykinin, same cytokine which causes pain, the leukotrienes secreted by the leukocytes, and it occurs very fast, like as soon as the endothelium comes in close contact with these mediators, they contract. So since they are contracting, they are making the space, and from these space the fluid can come out. That is your endothelial retraction. The second one is endothelial injury. As the name suggests, suppose this is your endothelium. This is inside your blood vessel. Now if you damage the endothelium from here, of course there is no endothelium now, so things can pass across it. This is seen where endothelial injury as a mechanism of the increased vascular permeability. This is seen in case of burns, severe injury. Sometimes microbes can also do it. For example, in sepsis, the neutrophils can also do it. Why neutrophils? Like, see, I told you there is space between them. Understand it this way. Here you can see we made the space between the endothelium. But tell me one thing, even if we made the space, first of all, this is space only between the endothelium. See, between the endothelium, but the basement membrane is still present here. Still basement membrane. So even if this is a cell, it wants to go out, It can go here, but it cannot cross the basement membrane. So we need to get rid of basement membrane. So what happens is, during the cellular phase, I will tell you, during the transmigration, this neutrophil will secrete matrix metalloprotease, and this will destroy it, the basement membrane made up of collagen. So neutrophils, if they can destroy the basement membrane, they can also cause the endothelial injury. So that is a mechanism by which vascular permeability increases. I told you to, but you can also, transcytosis. There are many, but you don't have to study. This is the main two by which it happens. In fact, if you have 10th edition Robbins, I think they will be, there. Like, let me see the image I might have. See this. This is the normal state. Here, the space between the endothelium, this is endothelium, this is endothelium, this is endothelium. Space was formed, and the fluid, they started to come out. This is your endothelial retraction. But in this part, you can see the endothelial was damaged. So this is endothelial injury, the another mechanism by which vascular permeability can increase. Now, if I am teaching you this, let's say, let's study this also. What is exudate and what is transudate? Exudate, it means this is exiting something. Transudate, it means it means across. It is moving across. Suppose this is your blood vessel again. This is your endothelial cells. This is also your endothelial cells, but they have space. If interstitial fluid is made across the endothelium, this will have very low level of proteins and all those stuff. But if they are made across the membrane, this is known as transudate, moving across, transudate. But if that is made from the space between the endothelium, that is exudate, as they are exiting blood vessels between the spaces. So this is two kinds of, the interstitial fluid. Normally, let's say this was your heart, it pumped the blood, it came to capillary. Now this is your cell. This is the mechanism by which, from the blood interstitial fluid will form, that will contain glucose, amino acid and everything. This is by which interstitial fluid is formed, the transudate. But at the time of inflammation, since there is, increased vascular permeability, the exudate is formed. So this was vascular phase. Now let's go to the cellular events. The समझ में आया? Did you understood everything? This is your cellular events. You have seven total cellular events. First one, tell me one thing. This is the blood vessel. You cause the contraction. Then you cause the dilation. What happened? Everything moved towards the periphery or towards the margin. So the first event of the cellular events, among the cellular events, is margination. This is margination, which is redistribution of all cells to periphery. Every cell will move towards the periphery, not just the leukocytes, not just neutrophils. Every cell will move towards it. But predominantly WBC, because WBCs are larger than the RBC. Got it? They will predominantly be towards the more periphery, because they are larger in size, so more centrifugal force will act on it. So this was our first phase, that is your margination. Second is rolling. Now rolling is regulated by selectins. Now what are selectins? See, a large number of cells moved towards the periphery. This can be RBC, it can be WBC, it can be platelets, or it can be some other cell. But inflammation, the acute inflammation which we are currently studying, they only want neutrophil. So you need some molecule which select it. So the molecule which selects it are known as selectins. What are selectins? Selectins are the receptors. They will firmly bind. Like this will be, like not so much strong bond. They will bind to it, but not so much strongly. That would be very firm binding. Now, there is firm binding, like it is, attached to it very firmly, but the blood is continuously flowing, right? So if this is the blood vessel, the neutrophil is here, it attached very firmly. What will happen? The blood is flowing, it will push it, so it will roll, it will come here, it will attach here. Again the blood will push it, it will come here. So what is it? Like this is just a neutrophil, this is just rotating, coming here, here, here over the endothelium. So got it? Like why am I saying, like where are we going with this? This is rolling regulated by the selectins. Selectins are nothing but the receptors. Now receptors always have a ligand. If this is a receptor, they will have a ligand. You can consider it like they are good friends, but there can be enemy. So ligands, the receptor say, how do I know you are the guy? He says, see, I am the ligand. You check my ID. What happens is ligands and receptor, there is a interplay of the proteins. They check whether the protein configuration, the configuration of the amino acid, the folding, whether they are according to their desire or not. They check it, and once they are checked, they form the bond, even though that is weak bond. Got it? So that they don't attract or attach RBC, because we need WBC here. So let's not make it so complicated. This is our rolling regulated by selectins. Selectins are receptors which helps firmly binding of neutrophil with endothelium. This is firm binding, and as the blood flows, it will push it, and this is pushed from here to here. Again blood flow will come here. So can we say this is rolling? This will cause the rolling, and this will continue to roll until it reaches a space where there is an exit, or it makes its own exit. Got it? This is your rolling regulated by selectins. Now selectins are what? Selectins are the receptor, and it can be of three types. It can be P-selectin, it can be E-selectin, or it can be L-selectin. P-selectin is present on platelets plus endothelium. E-selectin is present only on endothelium. L-selectin is present on leukocytes. Now, you might think, like, was it always there? Like, why selectins, the rolling is taking place right now only? Why didn't it happen earlier? Or was it happening earlier also? The answer is no. See, the thing is, if this is your neutrophil, the neutrophil always had this ligand, always. But the endothelium which have the receptor was not having the receptor on the surface. This was present inside the cytoplasm. But when there is inflammation, for example, tumor necrotic factor, interleukin 1, these factors are there, they come into the contact with the endothelium. This, selectin which was present inside will now come up to the surface. And now since this is contact with the surface, now this will bind with your neutrophil. Got it? So they are not always expressed. They are not always present on the surface. The ligand is always present on to the neutrophil, but the receptor on the endothelium are not present. One more thing, L-selectin, even though this is present on the leukocyte, it doesn't have any role in acute inflammation. It doesn't take part in the inflammation. While the P-selectin and E-selectin present on the platelet endothelium, platelet doesn't have any role in the inflammation. So P-selectin of the endothelium and the E-selectin on the endothelium only has role. It means if this is endothelium, it has P-selectin. Only this P-selectin has a role in inflammation. But normally this is present inside and not expressed. But if that is not present, expressed, where is it? Where is it? This P-selectin is present inside the endothelium in form of Weibel pallid bodies. Like not necessary here, but inside the platelets, this is known as alpha granules. Got it? Similarly, E-selectins are also present inside granules. So when interleukin 1, TNF alpha, they will come from the Weibel pallid bodies or the granules. They will come up to the surface. Got it? They will come up to the surface. These granules will disappear and then they will bind to it in a reversible manner. Blood will come, it will push. This one will go here. Interleukin will come in this part. It will stimulate endothelium of this part. This one from the cytoplasm will go above and it will bind. And this is how it happens. Now I told you the type of selectins. What about the type of ligand? If the receptor is different, the ligand will also be different. So there is a table. Let's say I'm writing L-selectin here, E-selectin here, P-selectin here. First of all, for acute inflammation, receptor is where? Receptor is on endothelium. And where is ligand? Ligand is on neutrophil. For the L-selectin, where is it present? Leukocyte. For E-selectin, this is endothelium. For P-selectin, endothelium plus platelets. Got it? Now, just see on this table. Distributed here. What about the ligands? For the L-selectin, the ligands are glycam1, madcam1 and CD34. What is CAM? That is cell adhesion molecule. And where is the ligand located? Endothelium. I said for acute inflammation, where is ligand located? Neutrophil. How is it wrong? Well, it is not wrong. I told you L-selectin does not take part in acute inflammation. So E-selectin present on endothelium. Ligand is sialyl Leuvel X. Where is ligand? Leukocyte. Similarly for P-selectin, distributed on platelets and endothelium. Endothelium P-selectin takes part here. What is the ligand? Sialyl Leuvel X. Where it is present? On the leukocyte. Got it? Did you get the selectin part? This is quite important. So Till now, the neutrophil is rolling. It is rolling. It is rolling. But it cannot, roll always, right? Otherwise, it will just stay there. Again, TNF, alpha, and interleukin 1 will act here. How will it act? Let's start our third, that is adhesion. Adhesion, what does it mean? It means sticking two different things. For example, you have adhesive, Fevicol. You stick paper with something like wood. So that helps in attachment of two different things. So adhesion is regulated by integrins. Integrins, as the name suggests, it helps to integrate. What it does is, previously we had form adhesion. This will form tight adhesion between endothelium and neutrophil. Okay, this is regulated by integrins, and we have two types of integrins, beta 1 integrin and beta 2 integrin. Previously we saw the receptor was on endothelium, but here the receptors are on cell, or you can say leukocyte, or we are studying neutrophil. Receptors are present on neutrophil. Previously it was on the endothelium, and the ligand previously was present on the leukocyte, but now ligand is present where? Endothelium. Got it? This time, if this is the endothelium, see, endothelium is very smart. It was keeping, your selectin inside. It also keeps the integrin inside. This is very smart, guy. This will be present inside. But once the TNF alpha and interleukin 1 acts over it, this integrin ligand, this was selectin, and this is the ligand of integrin. This will come up to the surface, and once it has come up to the surface, our neutrophil receptor will come and it will bind. This time binding will be so strong that blood flow will not be able to throw it, or it will not be able to push it. Got it? Now let's study the ligands for our integrin. For the beta 1 integrin, the ligand is V cell adhesion molecule 1. For the beta 2, our ligand is I cell adhesion molecule 1. Again, where are receptors? Receptors on neutrophil. Where are ligands? Ligands on endothelium. Endothelium was, saving selectin receptor and integrin ligand inside itself. It only expressed when it was outside. Got it? Now one more thing. Suppose this is our endothelium. Suppose this is our endothelium. Now the VCAM usually expresses over the surface, but ICAM between the ridge of the endothelium. Got it? Always remember it. Someone might ask you this question, maybe in a trick or treat. Now this one done. So we saw we had margination first, rolling second, third was our adhesion. The fourth one is known as transmigration. Trans means across, migration means movement. So this is the phase where the neutrophils will move across the blood vessel. How will that happen? See, again, blood surface, blood vessel, the endothelium, and here our neutrophil is attached with the help of VCAM. Now what it will do is, at this part, like let's zoom it. Suppose this is blood vessel, there is endothelial gap, the neutrophils are here, and they are attached to, let's say, ICAM. Even if neutrophil wants to go out, it cannot go out. Why is it? The thing is, even though there is space between the endothelium, there is the basement membrane. So this neutrophil will secrete matrix metalloproteases. What is it? That is matrix metalloproteases. Now since the basement membrane is destroyed, the neutrophil will form a pseudopodia and it will start moving towards periphery. And by this way, your neutrophil is out, and this is also known as diapedesis, transmigration or the diapedesis, which is the movement of leukocyte across the endothelial basement membrane. In this, we did two things. We pulled the neutrophil across the endothelium and across the basement membrane. Pulling the leukocyte across the endothelium was regulated by PECAM, which was found on the endothelium and the leukocyte, which helped pull the leukocyte. But pulling through the basement membrane, it required what? It required dissolving the basement membrane, which was our MMP. And matrix metalloproteases usually works in the presence of zinc from your zinc reserves. That is our transmigration. Now the neutrophil is finally free. This is present outside the blood vessel, and now it needs to go to the site of inflammation. But it's like, your brother called you to Delhi. You are in Delhi, but you don't know where is your brother. So maybe your brother will leave some signs. Maybe on Chandni Chowk, follow or go to this direction. When you reach here, it is written go to this direction, and here this is written go to this direction, and here is your brother. So this is a taxi, like this is a movement. Similarly, there are certain molecules which acts in a similar way, and your cell senses it and it moves in that direction. That is chemotaxis, like movement. The fifth stage is chemotaxis. What is chemo? Chemo means chemical. And what is taxis? Taxi, auto. That is movement. So that is chemotaxis. Movement in the direction of chemical or due to the chemical. Now, what chemical are they? Even in the when you were in your first year studying embryology, you were studying like when the sperm is deposited into the female reproductive tract, it starts migrating towards the fallopian tube. How does the small guy knows where is the fallopian tube? Because the oocyte releases many chemoattractants. Similar mechanism, the dying cells releases chemoattractants saying, hey, come here, bacteria is killing me, dude, like save me. Similarly, the pathogens are also releasing certain things. For example, they are shouting, like they think like they are winning, but their shout are attracting what? They are attracting you. You will go and you will kill him. So The shout is like a chemical and you are moving towards the south. For example, you are in your school, someone is beating your brother and or your friend, and your brother is shouting. The shout is like a chemical for you and you are moving towards that, and that is chemotaxis. Now, in the pathology, this chemical can be endogenous, as I said, which is present inside the body, or it can be exogenous, which is from the pathogen. Endogenous can be cytokines. For example, interleukin 8. It can be chemokines like interferon, or it can be complement proteins, for example C5a, or it can be leukotrienes. Leukotrienes are the chemicals which are secreted by the leukocytes so that they can communicate between them. This is leukotrienes B4. They causes chemotaxis. Similarly, from the pathogen, in the beginning I told you recognition by how does a pathogen how does a normal cell or antigen presenting cell recognize that this is a terrorist, this is a pathogen. They actually have toll-like receptor, nod-like receptor, and what do they sense there? They sense pathogen associated molecular pattern. Here also the exogenous chemokine, the exogenous chemical is nothing but the pathogen associated molecular pattern, which can be lipopolysaccharide, teichoic acid. It's like this. Here is the bacteria, and this is fluid. If you put salt, or let's say if you put color, you put color here, but it will go here also. So if there is polysaccharide or teichoic acid here, this is also fluid. Body is 75% water. It will move in every direction, and as the cell is here and it's moving, he will think no, he will go here, it will go here, but he will think no, there is no chemokine here. It will come back, it will go again here, he will think no, there is no chemokine, and it will eventually reach here. This is how chemotaxis works. For chemotaxis, you had two different kind of chemokines: endogenous, which was made by your own body, and you had exogenous chemokine, which was your chemokine from the pathogen. For example, lipopolysaccharide, the teichoic acid, and all of them are together known as pathogen associated molecular pattern. Got it? Now tell me one thing. What is the development of blood? That is mesenchymal. Yes or no? If blood is mesenchymal, your muscle is also mesenchymal. Any mesenchymal structure has actin. Here also inside the neutrophils, you have actins. Once you get the chemical stimuli, the calcium will start going inside the neutrophil. Once the calcium is going inside the neutrophil, you have G protein coupled receptor. This is secondary messenger, like you have studied this in the physiology. This will start polymerization of actin. Again, the neutrophil reached the side, neutrophil came in contact with any pathogen associated molecular pattern, but now it's need to move. How is it going to move? Neutrophil is also a mesenchymal structure. It means it also has actin, but this actin is not the filamentous actin. This actin is present in form of G-actin. G-actin. Now, once the neutrophil comes in the contact of pathogen associated molecular pattern, calcium will start going inside. This calcium will activate G protein coupled receptor. Once the G protein coupled receptor is activated, this will convert the G-actin or the globular actin into filamentous actin. So if the filamentous actin was formed inside like this, if this is neutrophil, this is like this, your G actin, this is now converted into F actin. Filamentous actin is like this. It will push, push the cytoplasm, cell membrane, and the cell membrane will form this pseudopodia. Similarly, chemoattractant is coming now from in this direction. Again, the assembly of actin will take place and the pseudopodia will form in this direction. This is the way by which your neutrophil will start, continue assembling actin. Pseudopodia will start forming, continue forming, and this will reach at the site. So stimulus caused the influx or the increase in the cytosolic calcium concentration. It activated G protein. Let's write it. Stimulus, which was the chemoattractant. Your cell sensed it. It increased the calcium concentration inside the cell. It activated G protein coupled receptor. Activated G protein coupled receptor causes the polymerization and it formed actin. Now actin is filamentous structure. In the muscle you have studied actin and myosin. This actin will, if this is the cytoplasm, this will push it. This will form pseudopodia and soon the cell will start moving towards that direction. Got it? So again a table. You have mediators, chemoattractant, can be endogenous, can be exogenous. Source, secreted by cell. Source, site of injury. Endogenous, you have LIC, Life Insurance Corporation. LIC, leukotrienes, leukotriene B4. I, interleukin 8. C, complement factor C5a. You have exogenous, for example, N-formyl methionine, bacterial cell wall product. Got it? So this is your chemoattractant. Now, in the school, 10 people are beating someone. You cannot do anything because you are also one, similar to your brother or your friend. What can you do to 10 people? So you will put a sticker over everyone's t-shirt. So you will put a sticker on everyone's shirt and you will leave him. You will call all your brothers. Hey bro, I have put a sticker on the back of shirt of everyone who beat my brother. If you find him, kill him. This neutrophil which reached this site will do opsonization. Opsonization means coating of microbe or any dangerous stimuli. I am writing in small here. Coating of microbe or any dangerous stimuli by opsins for effective and quick phagocytosis. Why effective? Because now you are not alone. There are thousands of neutrophils wandering around. Quick, because if there are thousands, they will destroy the 10 in a second. That is opsonization, coating of microbe or any dangerous stimuli by opsin for effective and quick phagocytosis. Now what are opsin? Opsins are the molecules used for coating. Those are CSF, cerebrospinal fluid. I'm kidding. C4, complement factors like C3b, C4b, C5b. This is a complement factor and this is used for coating or the as opsin for opsonization. S is for serum proteins. There are many serum proteins like fibrinogen, C-reactive protein. Now you got, why CRP is formed by the liver. CRP is formed by the liver so that it's coated onto the pathogen for quick and effective phagocytosis. And the F, which is the fragment crystallizable of immunoglobulins or antibody. See, if you don't know, if this is the antibody, if we use enzyme papain, this breaks the antibody in two parts. The part which binds with the antigen, this is known as fragment antigen binding, and this part which does not binds to the antigen, known as fragment crystallizable. So we use fragment crystallizable of antibody for this opsin, for opsonization, and fragment crystallizable of immunoglobulins is the most potent opsonin. Got it? And once you have coated, now your brothers know who is bad guy, who beated your brother or your friend, because they can see the sticker on the shirt of every guy, and they will beat him, or they will do phagocytosis. They will recognize everyone and they will destroy him. That is known as phagocytosis, and it was described by Elie Mechnikov. It occurs in three ways, or you can say three steps. First, recognition, because you don't want to beat the student who is son of a teacher, so you need to recognize whether the guy beated him or he is someone who you don't want to mess because of someone. So first you recognize. You have various receptors. You have receptors like mannose binding receptor. This is a receptor which binds to mannose. Mannose is a sugar. We have scavenger receptor. We have receptor for opsonin. These receptor will check whether it's boy with C3b, C4b, C5b, CRP, fibrinogen, FC or not. If that is, there will be second. They will engulf, like they will cover his head with a towel or something. That is engulfment. See this. This is the neutrophil. This was the bacteria. This bacteria was coated. The neutrophil will see it. They will recognize by receptor like scavenger receptor, mannose binding receptor, receptor for opsonin. They will engulf. How they will engulf? They will form this phagosome. Soon this phagosome will be like this, and soon like this, and the pathogen will be like this inside. Now you have engulfed. What? Engulfed the pathogen. You recognized it, you engulfed, and that is now inside the phagosome. Now this is just inside the phagosome. Tuberculosis bacteria, that is present inside the phagosome, and it stays like this. Most of the Indians are sometimes exposed to TB, and everyone has latent TB mostly, because in all of our cells mostly they are present inside the phagosome. Normally the lysosome binds with the phagosome and forms the phagolysosome and destroys the bacteria, but this MTB secretes various factors which stops the binding of phagosome and lysosome, thus stopping the formation of phagolysosome, and this stays. And when there is low immunity, the cell will die, the MTB will come out. So first was recognition, second was engulfment, and the third is killing. How do we kill it? There are a few mechanisms. First of all, if this was our neutrophil and this was our bacteria, this will go and it will bind, the phagosome will bind with the lysosome, and they will come inside a separate single membrane like this. And now this lysosome will destroy it. But how? How it will do the killing? This killing can be in few ways. It can be oxygen dependent. For example, it might use hydrogen peroxide or maybe halide. Or it can be oxygen independent. Got it? Let's see. Suppose this is one oxygen dependent. This is oxygen. We put NADPH oxidase. NADPH oxidase convert into O2 minus or the super oxide. This is a radical. This converts into hydrogen peroxide. Got it? O2 with the use of NADPH oxidase, it converts ultimately into hydrogen peroxide. Now this hydrogen peroxide is bombarded with myeloperoxidase. And this myeloperoxidase, in presence of chlorine, converts the H2O2 into HOCl or hydroxychloride. This is the most effective bactericidal. You know what is HOCl? This is nothing but Lysol. You know what we use for our floor cleaning? This is Lysol. It means you can say you are making Lysol in your own body. Yeah, we are making HOCl, which is the most effective bactericidal. We can attach the H2O2 with iodine and we can make hydrogen iodide. And this is very effective if there is a parasite. Got it? This was oxygen dependent. Second is oxygen independent. This is mediated by lysosomes. Lysosome has enzymes like lactoferrin, major basic protein. What they do is they will destroy the pathogen. Got it? Sometimes there is, like this is extra, frustration, phagocytosis. The cell cannot destroy it. What the cell does is it just pours the entire lysosome, like it will just put lysosome in environment. Got it? Now there is one more thing. There are certain things like sepsis. In sepsis, there is systemic inflammation. What happens is, in that condition, neutrophil cannot tag every pathogen. Like there are large number of pathogen. How many pathogen neutrophil can tag and personally attack and destroy? What it does is, the neutrophil has nuclei. Inside the nuclei you have chromatin. The neutrophil will destroy itself so that its nucleus comes outside. Once the nucleus is outside, his chromatin is also outside. Now what it will do is, if there is pathogen here, this is entirely pathogen. This is entire pathogen. This chromatin will go there and the thread, how fishermen use nets. This chromatin net will contain all of the bacteria. Now the macrophage or other pathogenic, or other inflammatory cell will come. It will engulf everything and it will destroy it. What is this process known as? This is known as netosis. In netosis, the neutrophil will kill itself so that its nucleus will come out. Once the nucleus is out, its chromatin thread will be spread in the environment that will trap the pathogens. That is known as our netosis. So with this we have completed acute inflammation. I tried my best to not just teach you but connect everything with the environment, like the UV and everything. Inflammation is very interesting. You can see inflammation in everyday life. If you or your friend or someone is wearing spectacles, chashma agar koi pehanta hai, on the nose ridge you can see 2 dots. What is it? The cells damaged there because of mechanical stress. Since the cell was damaged, it started producing melanin, because if there is the damage of melanocyte, it produces melanin. So you can see that is also an inflammation. Got it? So with this we are completing this topic for today, that is acute inflammation. I hope you guys understood everything, and if you don't understood everything, let me know. I will upload everything here, and maybe in the next topic I will discuss the inflammatory cells, because they are quite a thing. Because let's say this is neutrophil, polymorphonuclear cells. They have multiple lobe nuclei, but here do you see multiple lobe? You just see bent cells. See, bent cell everywhere, bent cell. So if you have the concept like this is going to look like multiple lobe, no, actually cells look different in smear and biopsy. This is neutrophils, this is eosinophil. Left side smear, right side biopsy. This is your lymphocytes, this is your macrophages. So maybe in the next class I will take the lecture on this thing, because it was supposed to be from the histology, and when I was teaching histology I had described this thing in detail. So that's it for today. If you have any doubt, let me know. Have a good day. Bye.